So I think probably 10 years ago, we would have found it sort of remarkable that we have these public 3D databases like Google Earth. And so here, for example, is a view of Toronto in 3D from Google Earth. But of course, we're talking about this over lunch. We all know that these models are not quite perfect. And so, for example, if you decided, okay, I want to know more about Toronto, so I'm going to zoom in to sort of a street view in 3D, we begin to realize, well, this isn't exactly what I experience when I'm walking down the street in Toronto. There's some details missing, for example. But there are more aspects to these problems. So, for example, things tend to get worse as you move away from sort of the center of the action in Toronto. So this is Google's current opinion of York University, which is essentially a flat plane. Well, it's located on a flat plane, but actually the buildings could not be three-dimensional. So this is not just a problem that York has. This is also a problem, for example, that Niagara College has, if you check. And so this is another aspect, another way in which these models are imperfect. So obviously, one of the things that has to happen over time is that we need to be able to make these databases more complete, more detailed, more accurate. And why haven't we done that yet? Well, of course, because it takes money. It's quite costly to build these models. And so in order to achieve this, I think we need to develop more automatic, more efficient methods for building these models. But let's, for the moment, suppose, so that's one goal of our project. But let's suppose for the moment we were to do that. I'd like to pose the question, will that be enough? And I'm going to try to argue that it will not. And this is my opening case of my argument, which is if my job was to sort of give you the experience of being at Yonge and Dundas Square right now, this is what I would have to work with from Google Earth. And the problem is not just a lack of detail. The problem is, of course, the experience of being at Yonge and Dundas Square is a dynamic experience. Right? I mean, it's all about what's going on there. It's about the people, about the vehicles. It's a dynamic experience. So the argument, the main argument of my talk is going to be that we need to think about how to bring these models to life by introducing the dynamics of urban environments. So the challenge then is that our 3D urban models are static, but cities by definition are dynamic places. So how can we breathe life into these models? So it's a big problem, but so one observation I'd like to make is that to a certain degree, at least, the data exists in the sense that most cities have substantial infrastructure in terms of video cameras in both the public and the private sector. This varies by country, but in general, this is true. And there are all sorts of numbers floating around about how many there are, and it's difficult sometimes to validate these estimates. But I think it's easier to talk about the size of the market in terms of dollars. And it's estimated that next year this market will be about $19 billion in sales for 2011. So this is a substantial investment in video architecture. So the question then is it possible to make use of video data in order to try to add dynamics to these 3D models? There are many potential problems, or potential challenges, let's say, in doing this. But perhaps the most fundamental, of course, is that these are 3D static models, but our video data, well, real time, are just two-dimensional. And so we somehow have to span this dimensionality gap, and three-dimensionalize these video data. There's another way of looking at this, which is more not so much from the 3D model side, but from the video side. So we have all this infrastructure, and what we find is that in many institutions, the way that this video data are consumed or used is something like this, where we have some unfortunate individual who is looking simultaneously at a wall of monitors, each of which is often multiplexed into different views, which are completely unrelated views of some complex three-dimensional site. And let's just hope that if something were to happen here, this gentleman will be able to figure out what's going on in 3 dimensions. It's a very difficult cognitive problem, and I think we have to ask ourselves, with all this technological sophistication, have we really thought about this as being the optimal user interface for using video data? So this is another way of looking at the necessity of thinking about three-dimensionalizing video data. So the whole talk, I guess, with the kind of argument manifesto I'm trying to put forward here is summarized in this slide. We have on the one hand this growing and more increasingly interesting three-dimensional geodatabase, which is static. We have this growing infrastructure of 2D video data. We need to think about combining that into some some fleeting.
You were thinking faster.
Yeah. This is where I get into the problem of what's forward and what's backward. Whoa. That just really went ahead. Some integrated system that's both three-dimensional and dynamic. And so I'm calling this a real-time urban awareness system. Okay. Now, I think we live in interesting times, not just because we have these databases like Google Earth and so forth, but because I think this problem of making these models dynamic is not yet in the commercial domain, but it is something that researchers like myself are thinking about. There's lots of interesting projects going on around the world. I think this is a good time for us to be working together, that is academic labs and industry and government agencies to make sure that some of this technology is developed in Ontario. Okay. And I think that it's not hard to imagine that if you were able to make these models more dynamic, that there would be many applications. Okay? And people tend to first think about security applications, particularly for very sensitive locations. But I think there are many more applications in terms of urban planning, traffic analysis, and so forth. Okay, so that's kind of the manifesto that led to the current project I'm going to talk about, which is called Three-Dimensionalizing Surveillance Networks. This is a project that's co-funded by GeoReferencing and OCE. We just completed the pilot phase, which was really largely a matter of getting the partners all together and trying to focus on the specific objectives that we're going to attack. So we've just started, as of last week, the actual full project phase. But I'll be able to tell you about some of the preliminary research that's led us to this point, and then a little bit about what we're hoping to do. So we have a very good academic team of top labs across the country, including people in geomatics and computer vision. So it's really very much a marriage between these two fields. I won't have time to talk about all the work, so I'm going to focus on the work at York. That is the work of Son, who's here. Maybe just raise your hand. Son, professor in geomatics at York, and work in my own lab. And the other thing I want to mention is that, of course, we're not the only ones in the world that are interested in this problem. And so we're fortunate to be linked to two Korean groups who are working on related problems, and in particular with Taejun Kim's group. And Taejun is actually here as well on sabbatical for the year at York, so we're very fortunate to have him as well.